In today's lesson, we're going to talk about the multiplication of matrices. Now for this, matrices do not have to have the same dimensions as one another, but they do have to have something about them that are equal. So in the first matrix, the columns need to be the same as the rows of the second matrix. And so here, if those two things match, that's why I have them denoted as n, then the dimensions of the new matrix that we get are going to be the rows of the first by the columns of the second. That's how we get m by k. Okay, so in order to multiply, we need to check to make sure that they actually work. So we need to look at the dimensions first. So the first matrix in this one is 2 by 2. The second one is a 2 by 3. So because those 2's are the same, that means we can. But then our resulting answer will be the 2 by 3. So then from here, now I can multiply my matrices. So how I do this is I multiply the first row of the first matrix times the first column of the second matrix. And so it's going to look a little weird, but you take the entries of both, so it's like 1 times the negative 1, and then 3 times the 0, and you add that to get your product. So essentially you're taking the first row, first column, and multiplying to each other to get that entry point, which if you notice, our entry that we're having here, or we're getting, is in the first row and the first column of our new matrix. So then I move on to the next one, where I take the first row of the first matrix times the second column of the second matrix to get that same entry point. So first row, second column. So that's how I know where I'm putting these and what I'm getting. So it's always a row from the first matrix, and it's always a column from the second matrix. So I do the same thing for first row for third column, and then I do the same thing for now I'm moving on to the second row, so I'm going to use negative 1, 0, and then I'm back to the first column where I use that negative 1, 0. And then second row, second column, so negative 1 times 5 plus 0 times 4. And then second row, third column, and get negative 1 times 2, 0 times 7. So it's almost like you're taking the row, twisting it to line up with the column of the second matrix, so you can get that multiplication. But once you have that set up, now it's just a matter of simplifying those values. So doing your multiplication and then adding them. So your matrix should be in the form of a 2 by 3, which it looks like we are in, and we also set it up that way. So I get negative 1, 17, 23 on the first row, and then 1, negative 5, negative 2 on the second row. And then that's our matrix for this multiplication. Okay, let's try another one. So for letter B, we first need to check. So it looks like I have a 3 by 2 with a 2 by 2. They match there, so my answer is going to be a 3 by 2. And then I do the same thing. So first row and then first column get multiplied. And then first row times second column. So notice that I complete a row here every time, and then I go down to the next row in the first matrix, and then multiply that with all the columns in the second matrix. And then I go down to the third row, and I multiply that to all the columns in the second matrix until I have my completed matrix, which have all entry points filled in. And then from there, I simplify. There's my answer. For letter C, your dimensions are 1 by 3 and a 2 by 2. Here, the 3 and the 2 are not the same, so I can't multiply. So I would say it's not possible, and that's my answer. For this part, we have some properties of multiplication of matrices. They are associative and they are distributive, so that's nice. There's another property that we want to talk about, but I'm going to demonstrate it more so in example 4 here. So for example 4, they want me to multiply the two matrices of AB, and they want me to multiply it in the other way, BA. Now I can do this because they're both 2 by 2s, so I'm going to get a 2 by 2 for each. And so continue that process. First row, first column, then first row, second column, and then second row, first column, second row, second column. So then from now, simplifying, so I'll get 68, 3, -3, -6 for the first matrix. And then I'll do the same process for multiplying B times A. Just flipping them around. So same idea, first row, first column, first row, second column, second row, first column, second row, second column. Okay. And what I want you to notice here is that we want to see if these two matrices are the same. And notice that they are not. If I set them equal to each other, they would not be equal because their entries don't match up. So in this case, we can kind of define that matrix multiplication is not commutative. And so that was the entire point. Okay? So just remember that you can't switch them around. The order does matter for matrix multiplication. Example 5 is pretty quick and easy. We have written matrix equations in augmented matrices, but we can also write them using separate matrices. So you can write a matrix for just your coefficients of x, y, z, then write a matrix for your variables. It's a variable matrix, and then that equals the solution matrix. We'll talk about this more in another video, but I just wanted to show you that you can set that up. We just don't want to solve. Okay, example 6 here says in a certain city, the proportions of voters in each age group who are registered as Democrats, Republicans, and Independents are given by the first matrix. The next matrix is a distribution by age and sex of voting population in the city. For this problem, let's make the highly unrealistic assumption that within each age group, political preferences is not related to gender. That is, the percentage of Democratic males in the 18 through 30 group, for example, is the same as the percentage of Democratic females in this group. First, we kind of needed to know which matrix is what. So let's go with the political one as matrix A, and then our gender one as matrix B. Now, because there's not a lot of room on this slide, I'm actually going to do my work on the next slide. And so to do multiplication of A and B, it's going to take a lot of room. So let's head over there. Now, your first matrix is a 3 by 3. Your second matrix is a 3 by 2. So those 3s, those inside numbers match because they're both 3s. So that means I can do this multiplication. So then my resulting answer will be a 3 by 2. And I go ahead and start multiplying. There's a lot of numbers for this one, so just make sure you give yourself plenty of room if you're writing this one down. Okay, so then I just kind of plug those into my calculator, which is fine, to get my final matrix here, which takes a while to do if you're showing all your work on each part, which I know you guys can use calculators, so we can just plug those in. So then now we can actually solve those answers. So here, letter B wants us to see how many males are registered as Democrats in the city. So to identify that, I'm looking for males and Democrats. So in the first column of the second matrix, it's males. And then in the first row of the first matrix, it's Democrats. So in my answer, when I multiply those two kind of ideas together, I'm going to look for the first row and the first column in my final matrix that I came up with, which is 13,500. So that actually tells me how many male Democrats there are. Okay. For letter C, it's saying how many females are registered as Republicans. So then I would look at the second column of the second matrix, and then the second row of the first matrix, because that's representing Republicans. And so look at the second row, second column in my answer, and that would be 10,950. So then there are 10,950 female Republicans. Okay? Hopefully you found this to be helpful. Thanks for watching.